Evan Forbes from Celestia. Take it away.
Hello, hello. Welcome. I'm super happy to be here. This is like my favorite place. I'm in Amsterdam. I'm in a cool nightclub-looking room filled with nerds. This is great. Okay, so I'm a core developer at Celestia. We're the first modular blockchain network, and we can get into that more later. But first, I'd like to talk about the quantum gravity bridge. So this is sort of like our new product coming out that fixes a big problem in Ethereum. Right now, if you want to deploy a rollup on Ethereum, you kind of have two choices. You can have great security, like effectively the security that Ethereum has today, but it's going to cost you. It's going to cost quite a bit of money. So you either have to pass that cost onto your users, or you have to light a pile of VC money on fire, or you can use something called a data availability committee. So instead of having the full security of Ethereum, instead of posting the entire rollup block onto Ethereum, you can just have a few people kind of sign over it and say, like, yeah, it's available. And that's the solution. Those are the two paths that you have, which is kind of crazy. So we wanted to set a third path. So you can kind of see here, like this is the daily cost. I took the screenshot yesterday. Fees on Ethereum right now are relatively low. And it's still, like for Arbitrum, it still costs them like almost $43,000 per day to run. So unless you have that money and you're a new project, you're kind of stuck taking like an insecure path. So yeah, posting data to Ethereum is like a big driver of these costs. So ideally, if we have like a third path, a different solution, then that would be great. So the idea behind the quantum gravity bridge is to have a rollup that can still be on Ethereum for settlement. It can still use Ethereum for consensus, but it uses Celestia for data availability. And this paradigm, or this new thing, is called a Celestium. So it's not a full rollup. It doesn't have the full security of Ethereum, but it's also a hell of a lot better than a data availability committee. So I like to think of this as the quantum gravity bridge. It's a light client relay. So the quantum gravity bridge is to a data availability committee as IBC, so the inter-blockchain protocol that Cosmos uses, is to a multisig bridge. So to those who don't really know what IBC is or what light client bridges are, light client bridges they basically verify the other chain. They don't verify the state, but they do verify that the validators of that other blockchain did actually sign off on this block. So depending on the proof of stake algorithm that's being used, or depending on the consensus algorithm that's being used, this kind of changes how these light clients are designed. Relative to a multisig bridge, you're completely trusting a few different keys. So there seems to be a new multisig hack every single day, but IBC has been out for a year. It's been transferring like billions of dollars of value, and it's still like totally fine. And part of the reason this is totally fine is because there's no like weakest link. So when you use a multisig bridge, that's the weakest link. No matter how secure both chains are, it's only as secure and good as that multisig bridge. So with IBC, if the header that you get, so it's a light client, so they exchange headers, if the headers that you get is invalid, then that means that 2/3 of the validators, the voting power that the validators have, is malicious. And at that point, you have to hard fork anyway. So there's not really this like weakest link. So this is why IBC is so great and multisig bridges are so terrible. So I have like, yeah, and one other benefit is that IBC is permissionless. You can just, if you really wanted to, you can relay your own transaction between chains. You can't do that on a multisig bridge. If a multisig bridge doesn't want you to move your transaction from chain to chain, you're stuck. So it's like, it's no good. Like, I kind of hate, like, I kind of feel a little bit bad of like making fun of multisig bridges so much because like they get hacked every day. It's like kicking someone when they're down. But at the same time, these things are really terrible. So I don't feel that bad. And people have been saying this for a while. Like they've been like shouting the dangers of multisig bridges and like these things are terrible. We shouldn't use them. It's not sustainable, et cetera, et cetera. And you can kind of say the same thing for data availability committees. These things are not secure. So we can look at comparing the QGB to a data availability committee. It's a lot of the same things. The QGB is light client-based. In order to update the QGB or do anything on the bridge, you have to have 2/3 of the validators of Celestia to sign off on something. That's kind of like the magic. There isn't like a weakest link here that is a bridge. So that's what I mean by like crypto economically secure, is there's a lot of stake behind these validators, behind that 2/3 that has to sign off on this. So if the 2/3 is malicious, then they can get slashed. They will get slashed. And I, like myself, and probably like quite a few of you in this room, if that happens to Celestia, we are going to hard fork, and we are going to slash the living shit out of your funds. Okay, so, and then the QGB also has one additional benefit that we can get into later. With Celestia, you can sample the data yourself. So you don't even have to trust Celestia's validator set personally. You can run a data availability light client and sample the data yourself. You can't do that with a data availability committee. So kind of like what I was saying before, data availability committees are not secure. Eventually, if we keep using them, we will see the same types of hacks that occur on multisig bridges. So like there was a $600 million bridge. I think we can have questions at the end. Yeah, thank you. So you can have a, like the $600 million hacks that we see, like that will happen in the future with data availability committees if we do not fix this now. So this is why we want to use a new thing, the quantum gravity bridge, to bridge data from Celestia to prove that it's on Celestia from Ethereum, so that you can build your rollup, you can have a much significantly improved security as opposed to a data availability committee. At the same time, it's much cheaper because Celestia was made to be a data availability chain. It's made to be modular. And that's not the case for like Ethereum. Ethereum is what we refer to as like a monolithic chain. So we can get into that more. But first, let's go right into like why Celestia is so good at data availability and why it's so good for this exact use case. Celestia is fully modular. So fully modular, that property of being able to use Celestia in sort of like this composable way, is because it's trust minimized. So it's trust minimized because it does data availability sampling and because it has fraud proofs. So if you're a light client and you are paying attention to Celestia, you don't have to trust the validator set at all because you convince yourself that the block data is available, and then you also listen for fraud proofs. So if anything bad happens, as long as you're connected to a single honest node in the network, you're fine. So part of the reason why Celestia is such a good data availability layer is because it doesn't have any execution. This is like a less is more type of deal. So because we don't have any execution, it's true, like we can't do settlement. You have to figure out settlement for yourself. Like you either have to pick a different solution or you don't really need settlement in the first place. But that has a huge benefit, and that Celestia doesn't have to have this huge state database. Like, one of the main reasons why it costs so much money to interact on Ethereum is because of the state database. It's this huge, big, bloated database, where on Celestia we don't have that. We have proof of stake, and we have transfers. That's basically it. So because we don't have to spend money on this giant state database, we can instead spend our money on bandwidth. And this is like a scaling factor. This is why Celestia is so good at being a data availability layer and nothing else. Because of this, because we don't have an execution environment, this also makes it easier to build. So I'm an engineer. I'm very thankful that I don't have to deal with like this very heavy execution environment. This would be very, very difficult and ultimately quite expensive. So because it's modular, because you don't have an execution environment, you can have something that's called a sovereign rollup. So this is not really been done before. You can have a rollup that does not have a settlement layer. It doesn't need a settlement layer. It's off by itself. You can, if you're a light client to that sovereign rollup, then you sample data from Celestia, and you also listen for fraud proofs from Celestia and from this sovereign rollup. And that's it. There's no trust involved anywhere. That's sort of like something that's like really new, and we still have to build. It's very exciting because there's just so many different things that you can do with that new primitive of a sovereign rollup. So Celestia uses can be this modular blockchain, and it can be so trust minimized because we do data availability sampling. Data availability sampling starts off with one copy of the data, and it creates several other copies of the data, and it does so in an error-assured way, so that the data is error-assured. This is similar to like a DVD or a CD. You can like scratch a DVD, and it will still play your favorite movie, because it doesn't need 100% of the data to be there. It only needs 50%, and then you can reconstruct the rest of the data. So if you organize it in this fancy way, you can basically, each time you sample, you dramatically lower the probability that a validator can hide any data. And this also has great scaling benefits because the more light clients you have, the more secure. Like the more people that are sampling randomly from the block data, then the larger block you can have. So Celestia is a very, 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 very good data availability layer. It should totally be used as a data availability layer, and this also makes it great to use for the quantum gravity bridge. Ethereum doesn't yet have this. They will have something similar with ETH2. But currently for ETH1, they don't have it, and this is sort of what we want to usher in. So we can see here the typical normal blockchain, like monolithic blockchain. You have Ethereum, they have execution and settlement, consensus, and data availability, all in one chain. With Celestia, you have just consensus and just data availability. You can pick your own settlement layer, and then you have whatever type of execution environment you want. You can use something with the EVM. You can use your own custom one. It doesn't matter. And then this last picture right here, this is, there is no settlement layer. You're a sovereign rollup, and that has its own benefits. Okay, yeah. So with the sovereign rollup, this is sort of like something that might not be the most intuitive, is that you don't actually have to verify every single transaction in a block. You can just ignore the bad ones. And if you do that, then you can have like these sovereign rollups. You don't actually need settlement if you just ignore the bad ones. But we can get into that more later or afterwards. Let's focus on the QGB. So Celestiums, this is the same slide from before. Data availability on Celestia, which again, Celestia is made for data availability. And then you can use settlement and consensus on Ethereum. You still have all access to your favorite digital assets, NFTs, etc. So the QGB works by being a light client relay. This means we don't verify the state of Ethereum. We do validate the commit. So if you know anything about Tendermint, we are just a fork of Tendermint. And as long as you have the signatures of 2/3 of the validators, then everything's fine. It's still, the validators could still be malicious in this case. We do have slashing in that event. And, but besides that, it's a light client relay. It's like things that we've already covered, like IBC. This makes it very, very secure, especially relative to a data availability committee. You can see a diagram here. So if you're a rollup operator, and how this works, how Celestiums work, is you post your transaction data onto Celestia. The validators create a commitment over that data. They sign it. They sign that new commitment. They post it on Ethereum. And then you have your rollup contract in the event that you need to prove that data was on Celestia. Then you can basically just query this contract. It's a very simple function. It's like a Boolean, like yes or no. Is the data there or is it not? And I think that we can definitely get into the contracts more. I would love to dive into the contracts afterwards if anyone is curious on how that works. But this is pretty simple. And for like something like an optimistic rollup, this is super, super efficient because you don't actually have to query this contract even unless you're verifying a fraud proof. Yeah, so the QGB has quite a few optimizations. So we batch things, so it's even cheaper to run from a relayer and an orchestrator point of view. So the validators that are signing things and relaying them to Ethereum, it's actually pretty cheap to run because we're batching every single byte of data that is on Celestia. We're sort of batching up and creating a commitment for and posting that commitment on Ethereum. And the same goes for validator set updates. So again, it's a light client relay. In order to be secure, you have to update the validator set as the validator set changes on Celestia. And we sort of batch these too. And again, it makes that very efficient. It's really cool because the way that we have this designed is that the relayer is completely trust minimized. So you only need one. You can only have one relayer, and it'll work perfectly fine and be just as secure. Ideally, you will have more, but you technically only need one. And I think that's good enough for now, yeah. It's very efficient. So we do have slashing, so this is like what keeps the QGB secure, is if validators decide to stop signing, we slash them. If they sign the incorrect things, we slash them. If they sign over two things differently, we slash them. This is like normal consensus stuff. It's extremely similar to just like normal Tendermint slashing, if you're familiar with that. And then we have some other cool stuff. So I think I already mentioned that with data availability on the QGB, you can sample yourself. So you don't really have to trust the Celestia validator set. You can just query yourself for whatever rollup that you're interested in. It has a one-to-many design, so this is really cool. All the light client relay, everything that's being relayed, is signed and available on Celestia. So you don't actually need permission to relay the block data from Celestia to any EVM chain. So right now we're only aiming for Ethereum because that's where it only makes sense. But maybe in the future, other EVM chains would want this functionality, and we literally can't stop you from doing that, which is kind of cool. In my opinion, that's really good design. It doesn't just have to be used for Celestiums. If you have any data that you want to prove that is available on Ethereum or any EVM chain, you can use the quantum gravity bridge for that. Yes, we're hiring. This is like the equivalent of like on YouTube where they tell you to like and subscribe. We have a lot of engineering positions that we're like starting to slowly expand our engineering team. Specifically, we're looking for Cosmos SDK engineers. We're looking for Go engineers, database, DevOps. But to be honest, if you're just a good engineer, you should just come and apply anyway. Even if you don't know these specific things, they're not that hard. I learned them.
And I think that's it.